All right, let's talk through week 3, task 2, so you can correct here. For the mean and the 5-number summary for both these data sets, well, really for this whole problem, I would put these numbers in your calculator. But there is our mean and our 5-number summary for both of those. Whoops, I lost my bar on my X bar. Now, I would go to the calculator to do the box plot, and you would go under second y equals, choose your list one, make sure you're doing the box plot with the outliers. But when we draw this, we want to make sure we know whether we're supposed to have outliers or not. And then we'll show the work in the end to support whether those outliers are not. For the first box plot, it should look something like that with one outlier. The second one, we have a couple outliers and just one of those unusual but can happen cases where Q3 and after we take out that outlier max of 22, the next highest point was also a 16, so there just wasn't a tail. As far as showing work to check the outliers, this step you wouldn't necessarily have to show, although I think it helps for most people to do it. Getting the IQR, Q3 minus Q1, and then multiplying by 1.5. That 1.5 is a constant we always use. Where your points start coming in is, you get 2 points for this step. 1 point for showing this with letters, 1 point for showing the numbers that you used. And then the same thing, 2 points for this. 1 point for showing the Q3 plus 1.5 IQR, 1 point for showing me the numbers that you used. Then we need to explain what those two numbers are. So anything below 3 or above 11 is an outlier. Then we can look at our data and say, okay, 15 is an outlier. Same thing over here. I think this is helpful to show. You could just jump right in here, though, and do Q1 minus 1.5 IQR. You could even do 13 minus 1.5 times 2 equals 8.5. That would be fine if you want to combine those steps. And then do Q3 plus 1.5 IQR and do 16 plus 1.5 times 2. That would be totally fine. Then explain what those mean. Anything less than 8.5 or above 20.5 is an outlier. So 6 and 22 are outliers. If you are going to make side-by-side box plots, we just need to make sure that we go turn on the second plot as well. So you'd want your calculator set up like this with both those data sets put in there. And then when you zoom 9, you should get both of your box plots. One super important thing to remember is to, and this is one that people often forget, is label these as well as what your scale is. Those are both really important, labeling of what's going on in your graph. If you're missing these labels, that's going to cost you because we need to know which data set is which. Now, this one didn't ask you to write any comparisons or anything like that. They just said, do these data support the belief that women have better study habits and attitudes toward learning than men? And then they explain that the scores on this SSHA, a higher score means better attitude. So when we compare these, there's several different ways you could phrase this. It does seem like this box plot is generally shifted higher than the male one. Now, because this outlier is here, this value is less than that one, but the true max is higher than the max. So I said it appears the data do support the belief that women have better study habits and attitudes toward learning than men. So that's just answering their question. But then we also need to support that. If you just started with that, you would not get full credit. So I said each value of the 5-number summary is higher for women than the corresponding value for men. So max bigger than max, Q3 bigger than Q3, median bigger than median, and so on. But I also said it's a little bit even stronger to point out some of the even bigger discrepancies, like the min for females is higher than even Q1 for males. So every single female is bigger than 25% of the males. You could also say that Q1 for the females is bigger than the median for men. So 75% of the females is bigger than half the men. These, even including at least one of these, is one of those things you can do to really strengthen your answer in the eyes of the grader. And then below is the 5-number summary for a set of data. Are there outliers? So this one's a little bit different. We don't have the actual individual data points, but we actually still can at least identify whether there's some outliers or an outlier possibly. Steps start the same way. Find IQR and 1.5 IQR. Then Q1 minus 1.5 IQR. Again, you could do 42 minus 1.5 times 12 if you want and show that all in one step. Then Q3 plus 1.5 IQR. So this altogether is 4 points on the test. Anything below 24 or above 72 is an outlier. Now here's where it's different. If we had the data, we would just look through the list of data to decide which points are outliers if there are outliers. The only thing we can do here is look at the min and the max. This says anything above 72 is an outlier, but our max is 70, so there are no outliers on the high end. Anything below 24 is an outlier, though. So all we can say is there's at least one outlier. The minimum itself is definitely an outlier. What we don't know is, are there 2 points at 23? Is there a 23 and a 20.5? Is there a 23 and a 23.5? Are there a couple points? That we don't know. But we can say since the minimum is less than 24, there's at least one outlier.